This is question number 70. It has three parts, parts A, B, and C. And so before I actually tackle this problem, obviously there is a much faster way to just know what the answers to these problems are, right, without having to graph. But let us graph these restrictions first. So we have our y-axis, our x-axis here, right? And so now when we're looking at this, the restrictions, right? So we're looking at values of x greater than 1, and we have to plot x squared. X squared is a quadratic function. So we still want to plot 1 though, right? 1 in for x squared. Although it does not say that x can be greater than or equal to 1, we still want to plot that 1 because there will be a hole at that point, right? So we have 1 times 1, or 1 squared, that's 1. So we know that we have a hole here at 1 comma 1. And then as we continue to increase the value of x, for instance, we put in 2, 3, we see that we get something like this at first, and it just becomes more of a quadratic function, right? So it continues to go there, right? Now when we're looking at 1 minus x for values of x that are less than or equal to 1, we can obviously substitute 1 into this linear function, right? And we get 1 comma 0. So we have 1 comma 0 here, and then we can plug in 0, right, in for x, and we get so if we plug 0 in for x, right, we would get 0 comma 1. So we would get something here, 0 comma 1, right? That would be 0 comma 1. And then we can plug negative 1, we would get positive 2, right? And so this one would look something like that, going onwards, right? Because it is x is all values for x such that x is less than or equal to 1, right? So we're looking at all values that are less than 1 as well. So, and that would just be a linear function that goes like this. This is obviously a quadratic function of x squared. So we have this, and now when we're answering these parts, it makes it much easier because we have limit of f of x as x approaches from the left hand side, right? So as we approach 1 from the left hand side, we are approaching the y value of 0. So for our answer to part A would be 0. Now as we're approaching limit of f of x as x approaches 1 from the right hand side, right, from the right hand side, we're approaching the y value of 1. And so now the question is limit of f of x as x approaches 1. That obviously in this case does not exist. Why does it not exist? Well, the one-sided limits are not equal. And as I said in my previous lesson, if you have a jump discontinuity, as we do have a jump discontinuity in this case, it is unlikely for a limit to exist because the one-sided limits are not going to be equal. You're going to have two different y values that your curve is approaching at for that one particular x value, right? You have a different y value that is being approached from this side and a different y value that is being approached from this side, right? So here you see that 0 and 1 are obviously not equal. The one-sided limits are unequal, therefore your overall limit does not exist. So when I was talking about doing a shortcut, right, instead of having to graph, you really don't have to graph because if you think about it, all you're really doing is plugging 1 in. So what I would do is personally, I know that x is greater than 1, right, for this specific restriction here. So when I plug 1 into this equation, I know that I get 1 comma 1, right? And so I know that for other values of x, I know that x is equal to 2, x is equal to 3, right? The graph is, we're really talking about the limit, right, as a limit as we're approaching 1 from the right hand side. This is what it means, that when we're talking about this restriction over here, because we have the restriction x is greater than 1, right, we're looking at values of x as we approach 1 from the right hand side, right? And then when we're looking at the restriction on top, 1 minus x, and x is less than or equal to 1, well, we're looking at when we plug 1 in, right, we get 1 comma 0, right? So we see that this restriction here is really talking about the left-hand sided limit, right? The left-hand sided limit. And the reason again is because our restriction here states that x has values less than 1. So obviously we're talking about this. We're talking about the 1 minus here, right? We're approaching 1 from the left hand side. So we know that that's what these two values are referring to. So that's what I would do. I would just take 1, I would plug 1 into this equation, plug 1 into this equation. I know 1 comma 1, right? So 1 comma 1, and then I know 1 comma 0 for left hand side. Therefore I know when I'm looking at the 1 minus, that's the left hand side. So therefore the y value of this coordinate here is 0, right? The y value of this one, right, is positive 1. That's the one that we're talking about for 1 plus, right? The one we're approaching from the right hand side, right? So that would be 1 here. That's just the y value of this coordinate over here. And then our final answer, whether the limit does exist or not, well, if we have 1 comma 1, and if we have 1 comma 0, and those y values do not match, then obviously we cannot have a limit, so the limit does not exist. So you really don't have to graph, right? You can visually know where your hole exists and whether those one-sided limits are equal or not, right? But obviously knowing that you have that jump discontinuity, clearly your limit in this case will not exist. So thanks for watching.